Today's lesson is day 3. We got page 19 and 20 for homework. You've got your warm-up. Go ahead and stick that in today's box. Pause the video to give yourself a chance to do it. And when you're done, hit play and a box will pop up for you to put in your answer. Now, exact distance, you should be keeping it in radical form. When you go to type in your answer, it'll be tough to type the root, so that's sometimes what you see for the abbreviation for square root, SQRT, and then put your number in. So if you had to do like 2 square root of 7, you would do 2 square root 7 when you have to type it in on Edpuzzle for your answer. So go ahead, pause it now, see if you can try the warm-up. So we'll have D equals, in parentheses we'll do x1 minus x2. So -2 minus 6 all squared, plus y1 minus y2, so 8 minus 4 all squared. This will give us -8 squared plus 4 squared. That'll give us 64 plus 16. So we have square root of 80. Go to your calculator, do menu number factor for 80. You'll end up getting 2, 2, 2, 2, and 5. 2 sets of 2, so 1 goes out front for each of those sets. So we end up with 4 square root of 5. Moving over to the homework. These two had you do the distance, but just to the nearest tenth. So fill everything in. Now, because you're rounding to the nearest tenth, you can just punch that radical in the calculator exactly as it looks, and then just be careful of where you're rounding to. When it says the nearest tenth and it comes back exact, it's a good idea to put that 0 in the tenth spot like you see in part B. Midpoint, you're averaging your x's and averaging your y's. So add your x's, divide by 2, add your y's, divide by 2. In 2a, you could have also had 21 over 2 for the x value, and that would be fine. And some idea in B, -0.3, comma 3.4. All right, so these next two are really common questions in this unit. So they give us the midpoint, and one of the endpoints, we got to find the other endpoint. So call the other endpoint xy. So -3 plus x over 2 and 6 plus y over 2 will give us the midpoint. Well, that should be equal to the midpoint of 1, 2. So set the x parts equal. 1 equals -3 plus x over 2. Cross multiply and solve, you get x is 5. Do the 6 plus y over 2 should equal the 2, the y value. Cross multiply and solve, you get -2. Write your answer as a point. So that's our coordinates for B, 5, -2. Same idea in the next one. Call coordinate f, x comma y. Add the x's, divide by 2, add the y's, divide by 2. Set them equal to the midpoint, solve, and you end up getting -3, 4 for the coordinates of f. We have right triangle. We know 2 of the 3 sides, do Pythagorean theorem. You end up with square root of 72, do your menu number factor. You got a set of 2's, a set of 3's with a 2 left over, so that'll be 6 square root of 2. And then in 6, we want it to the nearest tenth, so you can just put your square root in the calculator. Or sorry, not nearest tenth, nearest whole, so we'll have 279, and this one had units, so make sure to put your centimeters on your answer. So we're going to start on page 15. Today we're going to look at the slope formula and some equations of lines. So first off, earlier in the year we worked a lot with point slope form of a line. So you can fill that in the first gray box. Y minus y1 equals our slope m times x minus x1. When we work with that form, we fill in for the y1, the x1, and the slope, and then that's your equation. In this unit, we're going to work with the form that you saw in algebra in middle school more, y equals mx plus b, our slope-intercept form. where m is our slope and b is our y-intercept. Now, how do you calculate a slope? Well, slope is often said as change in y over change in x. There's our m that represents slope, so you're just doing a y minus a y over an x minus an x. It doesn't matter which one you have as the 2's and 1's, you just need to be consistent. So whichever y value you start with in the numerator, you need to start with its x value in the denominator. Be conscious of when you're subtracting, you sometimes might have minus a minus, which would turn it into a plus. And then the last two are things we saw earlier in the year. Slopes of parallel lines are equal to one another. And slopes of perpendicular lines are the negative reciprocals of one another. So if we had one slope as 3/4, its perpendicular slope would be negative 4/3. Reciprocal means you flip the fraction top to bottom, and then negative means you negate it, so the sign gets changed. On the bottom, the perpendicular bisector of a segment does two things. It's perpendicular to the original segment, so you need to find the slope and do the negative reciprocal, flip and negate it. And then it also passes through its midpoint. So when working with a perpendicular bisector, you will have to find the slope and then switch it to its perpendicular slope, and then also find the midpoint, and then we'll use that to find the equation of the line. So that'll be our main thing today, is working with perpendicular bisector equations. But before we do that, let's review from what you did back in algebra just to help find the equation of a line. So start out, we'll find our slope. So again, slope formula is y2 minus y1 over x2 minus x1. Remember, x's come first, y's come second. It does not matter which y value you start with, just be consistent. So I'm going to start with the y value of 5 minus our other y value, which is negative 6. Over, because we started with a y value of 5, we got to start with this x value of 2. Minus the other x value of 5. Minus a minus will become a plus. So this becomes 11 over negative 3, or in other words, that's at negative 11/3. So that's our slope. Now we'll use our slope-intercept form of a line, y equals mx plus b. Let's fill in that slope that we know. And then the other piece of information we need is we need to find the b value. Well, what we do is we take either of our points. It doesn't matter. You'll get the same answer. And we fill in the x and the y so we can solve for b. I'm going to take the first point there because sometimes it's nice to avoid negatives. So we'll put the 5 in for y. And then we'll put the 2 in for x. Now you can use your calculator as you're doing this. So in your calculator, we would do negative 11/3 times 2. That'll give us negative 22/3 plus b. We're trying to get b alone. So to get that negative 22/3 out of there, we'll add the 22/3 over because we need to do opposite operations. So again, you can just do this right in the calculator. 5 plus 22/3. That'll give us 37/3. And that's our value of b. Now just note, you're not done with the problem yet because you had to write the equation of the line. So to finish off, we've got y equals negative 11/3 x, and now fill in that b value of 37/3. So that's kind of a refresher of what you did in algebra when finding the equation of a line. When we do the perpendicular bisector, some of it will be similar, but we'll need the perpendicular slope, and our point we use will have to be the midpoint, not one of the endpoints. So down in part B, we're going to do the perpendicular bisector of this same line. Well, let's first identify our perpendicular slope. We already determined in part A that our current slope was negative 11 over 3. So our perpendicular slope, if we flip and negate that, will just be 3/11. Well, now we need our midpoint, because the point that a perpendicular bisector should pass through is that midpoint. Well, just like we saw on the homework, add your x's, divide by 2, add your y's, and divide by 2. So we're going to get either 7/2 or 3.5, and we'll get negative 1/2 or negative 1.5. Personally, I like to leave them as fractions, but if it's a terminating decimal, you could leave it as a decimal if you wanted. Now, we'll just work with our equation of a line and sub in our slope and our point. So we're going to have 3/11 x plus b. We'll fill in our x and our y now. So we're going to have negative 1/2 equals 3/11 times 7/2 plus b. Multiply those in your calculator, and you'll get 21/22. Subtract the 21/22 over. Again, you can do this all in your calculator. It'll calculate it for you. And when you do negative 1/2 minus 21/22, it'll give you back negative 16/11. It's really negative 32/22, but that reduces. So to finish off, just write your equation filling our slope, the 3/11, and our y-intercept. So we'll have minus 16/11. And that is the equation of our perpendicular bisector. A perpendicular bisector, say you had some line segment like this. Well, here's your midpoint. The perpendicular bisector goes through that midpoint and does so at a right angle. That's what we are finding, and these would be equal because segment bisector gives you a midpoint and the midpoint gives you two congruent segments. So the rest of this video, we're going to practice 4 more doing the equation of the perpendicular bisector. So hopefully after those 4, you'll feel really comfortable being able to do that on your own. So over on the next page, perpendicular bisector. So we want to think, okay, I got to do the slope, switch it to the perpendicular slope, and then also get my midpoint. Okay, those are the early things you need to do in a problem like this. So let's start out with our slope. So we'll take any y value. I'll take the negative 5 minus the other y value of 7 over, got to be consistent, so take the x value of the negative 5 minus the other y value, which is negative 4. Minus the minus becomes a plus. We're going to get negative 12 over positive 2, which is the same as saying negative 6. Well, now we want the perpendicular slope. Keep in mind, this is really negative 6 over 1. So when we flip it and change the sign, we're going to get positive 1/6 for the slope. So we'll leave that to the side for a second, and now let's go do the midpoint. So add your x's, divide by 2, add your y's, divide by 2. So negative 2 plus a negative 4 over 2, negative 5 plus 7 over 2. In the first part, we'll get negative 6 over 2, which is negative 3. Second part, we'll get 2 over 2, which is 1. So we've got our slope we're going to use, and we've got our point we're going to use. So we'll have y equals 1/6 x plus b. We'll fill in our x and our y. So 1 equals 1/6 times negative 3 plus b. So that's 1 equals negative 1/2 plus b when we sub that in. Add the 1/2 over, and we'll get 3/2 is equal to b. Again, all you got to do is just put those in the calculator, and it'll give you it right back. So our final equation now is y equals 1, 6x, and then our b value of plus 3/2. And this is the line that will cut our original line segment in half and do so at a right angle. All right, same idea. We want to find the equation of the perpendicular bisector. Slope-intercept form is just our y equals mx plus b form. So we need to think, find the slope, switch it to a perpendicular slope, find the midpoint, and then we'll be able to use those things to find the equation of the line. So starting out with our slope, we'll do a y value minus our y value. We started with a y value of -4, so we'll start with an x of 3 minus the other x value, which is -1. Minus a minus gives us a plus. So this is going to give us -7/4. Now do your perpendicular slope. We'll flip and negate that, so that gives us +4/7. We'll do our midpoint now. So that's 3 plus -1/2, -4 plus 3/2. That'll give us 2/2, which is 1, -1/2, which is -1/2. We'll now use that midpoint and the slope to write the equation of the line. So we'll have y equals 4/7 x plus b. We'll fill in our x and our y. So we'll have -1/2 equals 4/7 times 1 plus b. So that's -1/2 equals 4/7 plus b, because anything times 1 is just itself. To get the 4/7 to the other side, we got to subtract it over. And -1/2 minus 4/7, when we put that in the calculator, will give us -15/14. We're not done though. We've got to write our equation actually. So that's y equals 4/7 x minus 15/14. All right, one last page for this video. So if we look at page 18. So this time they give us the midpoint. So that's good. We're not going to have to calculate that. And they give us the coordinates of one of the endpoints. So let's just kind of draw a little visual here. So here's point R. Here is our midpoint. So that means our other point is right here. Well, the other thing we need to find the equation of the perpendicular bisector is the perpendicular slope. Well, notice our slope between our endpoints is the same as the slope from R to the midpoint. So we can just use the midpoint in R in order to find our slope to get the perpendicular slope, and then we'll already have the midpoint to sub it. So these will actually be a little bit less work because you don't have to calculate the midpoint. So we'll just use again, our midpoint and the one endpoint for our slope. So we'll have -1 minus, oops, nope, take that back. Let's start that again. So we'll start with one of our y values, so 5 minus 9. If we started with 5, we got to start with -1 in the denominator, minus a -4. This is going to become a plus, so we'll have -4 over +3. Our perpendicular slope, when we flip and negate that, will be a +3/4. So we will use that and the midpoint, which they already gave us, so a little bit less work, to find the equation of the perpendicular bisector. So we have y equals 3/4 x plus b. We'll fill in our x and our y. So that's 5 equals negative 3/4 plus b. And to get b alone, we'll add the 3/4 over. And we'll end up getting that b is 23/4. From there, we'll finish off by just writing the equation. Y equals 3/4 x plus 23/4. All right, last problem for today. We're given the midpoint of MD. Then they give us the coordinates of D. We want to find the equation of the perpendicular bisector. So it's exactly the same as the last one. They already gave us the midpoint. So great, we can use that eventually. And remember, the slope between your endpoints is the same as the slope between an endpoint and the midpoint. So we'll just use these two that they gave us to calculate our slope so that we can then find the perpendicular slope. Nine minus 4 will give us -5. Minus and minus becomes a plus. So we get -4. A negative divided by a negative is a positive. Perpendicular slope, flip and negate it. So we got -4/5. And we'll use that in our midpoint to find our equation of our perpendicular bisector. So we've got -4/5 x plus b. We'll fill in the x and the y. So 9 equals -4/5 times -7 plus b. Just put that in the calculator. -4/5 times -7. That'll give us 28/5. Again, it's best, I would say, to keep things as fractions. We'll subtract that over. In your calculator, just do 9 minus 28/5. And that'll give you 17/5 for b. To finish off, we'll just write our equation. So we have y equals that -4/5 x. And then we've got that 17/5 for b, plus 17/5. So we've got lots of examples in this video of finding the perpendicular bisector. If you're doing the homework and you get stuck, go back to the examples, see what we did, and use that to help you out. Use your calculator to multiply the numbers, add or subtract the numbers. They're not always going to be nice, but your calculator will do it easily for you. Make sure to be using your fraction template when you're doing it. Control divide gives you your fraction template. That's it for this video. Have a great rest of your day.